All right, well, I'm seeing that number of people joining starting to slow down, so I think we'll go ahead and get started. Everyone hear me okay? Great, all right, some thumbs up. So thank you all for joining today. I did want to share that we have an icebreaker question in the chat. I think most of you have responded by now. And I really appreciate these responses because I think it will tie in really well with the topic of today's webinar, which is on warming temperatures, nighttime warming, and extreme heat in North Carolina. And some of the responses that came into the chat on who is most impacted by heat in North Carolina were really wide ranging. Everyone from homeless or people who maybe are poor or lack air conditioning to animals and plants, cattle, farm workers, construction workers, people who are outside all the time. So really, heat isn't something that just affects a few or just affects small segments of our society. It really is wide reaching. And it's nothing that, it's not trivial either. So I'm excited that we get to delve into this today. I think we have a really great lineup of speakers here to talk with us. So just a little bit about the upcoming webinars in the series. So today's webinar is the second in a 6-part series covering different aspects and impacts of climate change in North Carolina. The next webinar will be in October and will cover hurricanes and extreme precipitation. We'll follow this in early November on drought and wildfires. And then we have 2 webinars that we just scheduled in December to wrap up the series. One will be on sea level rise, and then the final one will be on talking about climate change. And we hope that that last one will be a way to be a little bit more of an interactive experience for attendees to really get some hands-on experience. A lot of you I know are already registered for these upcoming webinars. I will send out that registration link in a follow-up email. If you can't find it or for whatever reason, it slips down in your inbox, just shoot me a note and I'll make sure that you can get signed up. Everything, all the webinars in this series are being recorded. I just clicked the record button again. And everything will be posted to our website, which is there at the bottom of the slide. So, let me go to my next slide here. All right, so this series is being hosted by my center, the State Climate Office of North Carolina, in collaboration with the North Carolina Institute for Climate Studies, or NCICS. And the idea for this series came from needs that we heard from many extension agents and their clients across the state, really wanting to have trusted information and expertise about climate change to help with day-to-day communications and operations and planning. And so with the recent release of the North Carolina Climate Science Report, we thought this was a really opportune time to host a series on this for extension agents and our other partners in the state. And so just a little bit, my name is Rebecca Ward. You all have probably been receiving lots and lots of emails from me in the past couple of weeks. I work at the State Climate Office. We have mission areas in applied climate research, extension and education, and monitoring. And we work really closely with different sectors across the state, including agriculture, and work really closely with extension, studying climate environment challenges and research questions, and really try to be this climate knowledge resource for North Carolina. And then my partner in planning is Tom Maycock with NCICS, and I'll hand it over to Tom now.
Thanks, Rebecca, and thanks for all the heavy lifting and organizing this. Rebecca does almost all of the work. So welcome back to those who are at the first webinar, and welcome to those who this is the first time you're attending. As Rebecca mentioned, I'm with the North Carolina Institute for Climate Studies, and we're based in Asheville, and we're normally co-located with NOAA's National Centers for Environmental Information, which is the NOAA Archive for Climate and Weather Data. And we support their mission in pretty much all of its aspects, but we do a lot of other work too. And one of the things we did was lead the development of the North Carolina Climate Science Report in partnership with the State Climate Office and experts from around the state. And so that you'll see some results from that in Jared's presentation. And I did want to mention that hopefully next week we're going to release an update to that has improvements to the accessibility. The big change being alternate text for all the figures and images for folks who are visually impaired and use screen readers. So either next week or the week after, we'll get that out, and you can find that at ncics.org/NCCSR. And next slide, I guess, we'll talk a little bit about our logistics for today. So you probably are all too familiar with Zoom at this point, but just a reminder, we'd ask you to please stay on mute while you're listening, just to avoid background noise. Many of you have already found the chat function where we've asked you to respond to our icebreaker question. We also invite you to post any questions throughout the session in the chat box. We'll be collecting those in a separate document, and we'll deal with those in the Q&A period. If we have some clarifying questions, we may work those in during the session, but we'll try to get to as many of those as we can during the panel discussion. We'll also be posting a document with the questions and responses after the meeting, along with the recording. You'll also have the opportunity to raise your hand if you want to ask your question verbally. We'll show you how to do that when we get to the Q&A session. And I think that's it. Yeah, we'll introduce our speakers. First up will be my colleague Jared Rennie, with sort of an overview of heat and temperature changes in North Carolina. That's followed by Jen Runkle, another of my colleagues, and her partner Maggie Sugg on health effects on populations of concern. Matt and Clyde will be talking about arthropods in a changing climate, and Lauren will be talking about heat health systems in rural North Carolina. So you'll see a lot of overlap with some of the vulnerable populations that you've mentioned in the chat. So I want to introduce Jared to lead things off. As I mentioned, he's one of my colleagues here in Asheville at NCICS. He's a certified consulting meteorologist, and he focuses mostly on analyzing surface temperatures and applying that to real-world applications. And that's what you'll hear him talking about today. Unless something has changed recently, I don't think he's had a haircut since March. And as a native New Englander, he has some thoughts and feelings about summers in North Carolina, which I think has influenced his research interests. So with that, we'll hand it over to Jared, and hope you all find it interesting.
Well, thanks, Tom. Yes, not that I'm tracking, but my last haircut was on December 23rd, 2019. So I am making it an effort to not get a haircut in 2020. It's just a personal goal of mine. Anyway, all right, so let me go ahead and share my screen here. Let's get this set up. And I'll start the presentation. Okay, so can I just get a thumbs up that you all can hear me and can see the slides? Great, let's get to it. So, so again, I just want to thank Rebecca and Tom for setting this up and for inviting me to come talk to you all today. Yes, I am from New England. I do have opinions on heat, but I will try to keep those a little limited here because I am up in the mountains of North Carolina. So it's a little cooler than other places in the state. And we'll talk about that a little bit. So let's just jump right in. So we're talking about heat and temperatures. So what do we know about temperatures? Two basic quick things is that it's very easy to calculate with or to record with a thermometer. And we have lots of them, lots of thermometers all over the world. As Tom had mentioned, we are in Asheville, North Carolina, alongside NOAA's National Centers for Environmental Information. Their claim to fame is basically they hold all the world's weather and climate data. And the most common variable we have is temperature. We have it pretty much scattered all over the globe. And we have records going as far back as the 1700s. We have them, back then we have all these paper records and they've been digitized, and we have them on computer servers. And this map here is kind of showing where the ground observations are. And just a couple quick things from this image. We've got lots of coverage in the US spatially and in time. We have, data going back hundreds of years. And around the world, it depends on where you are, but most of Europe, they have the sort of longer periods. These are the stations that go back to the mid to early 1700s. And then the rest of the world is kind of scattered depending on, if they have a station there or not. We also have satellites out in space that record temperature. Those have only been around for the past few decades. But because temperature is sort of our most common element, it's very easy to aggregate this information and do, apply it to mathematical equations and kind of take the Earth's temperature. And we're able to do that for hundreds of years. And so most of our reports that you see, whether it's from the state climate offices or from NOAA or others, the most common thing they talk about is temperature. So what do we know about temperatures and how they've changed over time? So let's start big first, and then we'll come more local to North Carolina. So globally, the temperatures have increased since the 1940s over the world. This graph here, I believe, was provided by NOAA. They're not the only ones that do this type of analysis. There's a group at NASA that does something similar. There's a group out in the United Kingdom that does it. There's a group in Japan, and then there's also a group in Berkeley, California. They do a analysis as well, but they all relatively say the same thing, in that there's been this increase in temperatures over the past few decades. It depends spatially. This map here, this is what the temperatures looked like last year. In 2019, 2019 was, whoa, let me go back. 2019 was the second warmest year on record for the Earth. And this is sort of what it looked like. Parts of the US actually saw cooler than normal temperatures. But, we call this global climate change. So, there's other parts like in Africa and up in the Arctic and Europe that had really warm temperatures. And I have the last 5 years here as the ranks where they stand against its period of record, which goes back to the 1800s. And the top 5 warmest years have literally occurred the last 5 years. So it's unprecedented warming that we're seeing. Honing down on the US, somewhat the same kind of information. We have this time series that goes back to 1895. And this is for the lower 48 states, the contiguous US. And you can sort of see some trends here. There's this really warm period in the 1930s. This is sort of related to the Dust Bowl period, really dry conditions, really warm temperatures during that period. And then there was sort of a cooling in the 60s and 70s. But since the 1980s, we've seen an increase in temperatures, similar to the world. Again, it depends on where you are in the US, where you're seeing more warming. A lot more warming is happening in the western part of the US, parts of Florida, parts of New England, and parts of North Carolina as well. So now let's go into North Carolina. So the next few slides, there's going to be a lot of images. And all these images and this information is actually, it's come from this North Carolina Climate Science Assessment Report that was released some time ago, but as Tom said, a newer version's coming out in a week or so. Okay, so here's the time series for North Carolina. You see sort of the same kind of trends. You have this warm period during the 1930s, this Dust Bowl period. There's this cooler period during the 60s and 70s, but this rate of change that has increased substantially since the 1980s. And some statistics from the report, the decadal period between 2009 and 2018, it was the warmest 10-year period on record in North Carolina. It was about 0.6 degrees warmer than the decade in the warmest 20th century decade, so that's the 1930s. And 2019, here's the ranks for the past 5 years. 2019 was the warmest year on record. You have 3 of the top 5 warmest years happened very recently, and the year's not over yet for 2020, but 2020 right now is on pace to be probably in the top 5, but we'll see how things go over the next few months. Okay, so I have a poll, and I have never done a poll before on Zoom, so this might break badly. I'm actually going to ask Rebecca if she's able to launch the poll. So while that gets launched, I'm going to kind of just talk about this a little bit. So where are we seeing most of the warming in North Carolina? So is it during the daytime when the sun is out, or is it at night? So I'll just I'll let it go for about 30 seconds, maybe 40 seconds, and we'll kind of talk about this a little bit. Okay, so we have about 90% of people that have voted. So most of the answers say nighttime, and that is correct. The answer is nighttime. It is a little counterintuitive. A lot of people, when they think of warming temperatures, they think of when the sun is out, and that it does have we do have warming during the daytime, but it's more substantial at night. And we'll talk about why that's the case in a few slides. So let's see here. Okay, so again, this is from the science report. On the left, these are sort of daytime temperatures. This is the number of what we call very hot days. Here, a hot day is defined as a day where the maximum temperature during the daytime is greater than or equal to 95 Fahrenheit. And on the right here, this is the nighttime information. So we're calling this very warm nights. This is days with minimum temperature greater than or equal to 75 degrees Fahrenheit. And this is for the entire state of North Carolina. You sort of see this similar trend that I talked about before. You have sort of these large numbers during the Dust Bowl period, these low numbers during the 60s and 70s, and then a higher number more recently. But what's different here is sort of this rate of change. The rate of change in the number of very hot days, it's not really increasing or decreasing per se. But if you look at the very warm nights, we're actually seeing an increase since the 1980s. So yes, for those that said nighttime, we are seeing much warmer nights than the days. And it's not just North Carolina, a lot of places in the Southeast United States are seeing this. So, obviously there's 100 counties in North Carolina. So we want to kind of split them up into different regions. This is graphics actually from the North Carolina State Climate Office. They've split the state into 3 different regions. There's the Western Mountains, so this includes cities like Asheville and Boone and Cullowhee. Then there's the center part, which is called the Piedmont. This includes the big metro areas such as Charlotte, Greensboro, Winston-Salem, and then it includes the Research Triangle, so Raleigh, Chapel Hill, Durham. And then you have the coastal plain that includes cities like Wilmington and Greenville, and then the Outer Banks and the other coastal areas of North Carolina. So the report actually splits up a lot of these results into those 3 regions. And the next few slides will kind of go over that, and it'll have there's 3 images on each slide. There's the Western Mountains on the left, the Piedmont in the center, and the coastal plain on the right. So this is the just average temperature by region. They're all relatively saying the same thing. I should point out the math nerd in me wants to point out here that the y-axis is different for all 3. That's generally because the Western Mountains, are at higher elevations. We're usually cooler here. And then as you start to go eastward, you typically experience warmer temperatures as you go down the mountain and over to the coast. But the same trends are similar here. Warm period early, a little cool period in the 1960s, 1970s, and then some warming since the 1980s. And that's the case for all 3 regions of North Carolina. This is the very hot day, so this is the daytime maximums. Again, same sort of result here. You're not seeing huge change over time. There's still noticeable amount of days in the regions, but we're not seeing, the report I believe says that we're not seeing a substantial increase or decrease in this information. What we are seeing an increase in is, again, these nighttime temperatures. You have this increase since the 1980s, and it's more prevalent in the coastal plains of North Carolina. So the question that might be on everybody's mind, it's like the $1 million question: why? Why are we seeing more warming at night? There's a lot of research on this. It can kind of boil down to a couple things. We have in the weather world, we have this, we talk about radiation a lot. So during the daytime, we have solar radiation that comes in from the sun. And then at nighttime, we have this, what we call infrared radiation or long wave radiation that sort of escapes the earth. So what happens is when you have a clear sky at night, you have this radiation able to escape the atmosphere. And as a result, that actually causes cooling. So that's one of the ways it can cool at night. So this is just sort of this graphic kind of shows that. Now, when you have clouds in the sky, it kind of acts like a blanket. And that blanket, it prevents some of this infrared long wave outgoing radiation. It prevents it from escaping the atmosphere. And what it does, it kind of absorbs it and then actually sends it back to Earth. And what that actually does is it creates some warming. Now, I haven't talked about it just yet, but not only are we seeing an increase in temperatures, we're also seeing an increase in water vapor. And water vapor is one of the ways in which we can get clouds. So we're seeing an increase in the amount of cloud cover. And what that's doing is it's kind of keeping that blanket at night, and it's preventing this radiation from escaping, and it's preventing this cooling. Not only is there an increase in humidity, there's also an increase in greenhouse gases. So we're adding CO2 and other greenhouse gases into the atmosphere, and that also acts as a blanket. It prevents this radiation from escaping. And when you have that exacerbated by clouds and increased humidity at night, then it's helping keep things warm at night. So that was just a very basic overview as to why we're seeing an increase in warmer temperatures at night. Okay, so how do they look moving forward? We know that things have changed over the past few decades. Another question that people want to know is, well, what's going to happen, over the next decade? What's going to happen over the next few decades? What's going to happen by the end of the century? So the science report does talk about that as well. We use climate models to sort of project this information out to the end of the century. This is specifically for North Carolina. One thing I should note is that there's two different scenarios. So we kind of call it a higher scenario and then a lower scenario. The higher scenario is essentially business as usual. We don't make any major changes, and there's no change to curbing emissions. It's sort of a business as usual as we move forward. The lower scenario is if we start doing some if we start taking some action, like going over things like the Paris Climate Accord, or following the guidance by the IPCC or other organizations to cut emissions and such. So the first thing for North Carolina is that regardless of scenario, the next 20 years, so here we are in 2020, the next 20 years, regardless of scenario, we're going to see pretty much the same thing. We're going to see a slight increase in temperatures for the state of North Carolina. The important piece is what's going to happen after 2040. And this is where these sort of two emissions kind of diverge a little bit. If we go on a business as usual route, temperatures will continue to increase to, probably, 8 degrees, 10 degrees by the end of the century on average. If we follow the lower scenario, it'll increase a little bit, but then it'll sort of curve off and flatten out by the end of the century. And this is the same for all three regions of North Carolina, but I don't have those images to show you. This is sort of what it looks like spatially for North Carolina, for very hot days on the left and very warm nights on the right. So again, regardless of scenario, we're going to see relatively the same things for the next 20 years. There will be increases in the number of hot days and warm nights. Probably, just looking at the color bars here, probably, 5 to 10 days annually as an increase over the next 20 years. And then things start to diverge after the year 2041, and it depends on which scenario we follow. We're going to see increases in both cases, but if we follow along sort of the business as usual scenario, we're going to see a substantial increase in the amount of hot days and warm nights by the end of the century. Some of you might be wondering, this is all great, but I want to see local. I want to see information for my town or my county or my district. There's a group here in Asheville called NEMAC. They have heard that request, and they've sort of followed through. There's this website called the Climate Explorer. I have provided the link here for you all to jot down, but it's also going to be, we're going to provide this to you after the talk as well. It's a great website. What you see here is just one small piece of what they do, but this website piece you can put in a county or a city, and it'll give you the graph similar to what I've just shown you. So this is for Buncombe County, which is where I am. This is where the city of Asheville is located, and they've got what it has looked in the past, and then it's got the two scenarios. Red is the higher scenario and blue is the lower scenario, going out to the end of 2020. It's a great website. I'd highly recommend it, and it's a great group of folks over there. I have one comment about this sort of cliche statement. It's not just the heat, it's the humidity. So, when you add humidity into the atmosphere, it sort of, our bodies can be affected by that. When it's really warm out, your body tends to sweat, and when it's dry out, it actually helps to evaporate the sweat on your skin, which actually leads to a cooling effect on your body. When you have an increase in humidity, you actually don't have that ability. And as a result, your body temperature can actually be exacerbated by that. So there's some research out there that talks about this. The National Weather Service, they've actually incorporated something called the heat index. You've probably heard of this. And it incorporates both temperature and humidity. And as a result, in North Carolina, when you have a very humid afternoon, your heat indexes can be very high. So if you have, if your daytime temperature is 90 degrees, but it's very humid out, your feels like temperature could be into the hundreds in some cases. And this is just a graphic from folks at Climate Central that have tried to look at this a little bit. This is sort of the change in number of days with heat index greater than 90 degrees Fahrenheit since 1979. This is nationally, but for North Carolina, every area except for Asheville has seen an increase in the number of days with a heat index of 90 degrees. And we expect the similar thing to happen going to the end of the century, similar to temperatures. And then I will briefly mention this one other index called wet bulb globe temperature. You may have heard of this. It's a relatively new concept to think about heat. It incorporates heat and humidity like the heat index, but it takes into account two other effects as well. So it does take into account solar radiation, and then the solar radiation can, if your skin is absorbed by this radiation, it can, increase your body temperature. And then the other variable it incorporates is wind speed. So wind can actually help cool you down. It can, it can help evaporate the sweat off your skin and lead to a cooling effect. Again, this is a fairly new concept. The Weather Service in Raleigh is actually utilizing this. So if you actually go to their website, you can actually see a forecast for wet bulb globe temperature, and it's used by people, it's used by groups in OSHA. Outdoor workers have started utilizing this. The Department of Defense, the military, they're the ones that actually sort of derived this variable. They use it for outdoor operations, and there's also athletic associations, high schools, that use this for their outdoor practices, especially if you're in the Piedmont in August and September, it's really sultry out. So they actually have started using this to dictate how they practice outside. Okay, another $1 million question. Why should I care? Some people might say, well, okay, it's going to be a little bit warmer, a few degrees warmer. That's actually not bad. Maybe you can go to the beach, later in the year, or, I like warm temperatures, not me, but I know a lot of people like warm temperatures. They may, hey, this isn't so bad. So why should I care? Well, heat affects everybody one way or another. And I'm only going to talk about a few, and we've also got speakers to talk about this as well. But there's different sectors that we can kind of go into and talk about a little bit. So I'm going to start with the energy sector. So this graph here is just for Raleigh. And this records something called cooling degree days. So that's essentially a variable that relatively dictates how much electric demand is needed, depending on how hot it is. And we've seen an increase, at least in Raleigh here, we've seen an increase in cooling degree days. Now, we talk about nighttime warming. I may not care because I'm sleeping, but my air conditioner cares because, it's going off all night now, when maybe back in the, 1980s, 1970s, it didn't. And as a result, the energy companies care because there's higher demand at night. So they're very interested about this warming because of the increase in demand. And I know out in, in parts like California, they have blackouts and brownouts that affect them almost every summer. So in the energy world, they're very concerned and interested about this increase in warming. Switching sort of to agriculture. So this is another metric called growing degree days. it's a similar way of calculating demand, but instead of energy, it's, for planting. It's trying to dictate, when things start growing, when you should start planting, what's your yield going to look like, how long's the growing season. And we've also seen an increase of this over time, again, in Raleigh, but this is, if we could map this for North Carolina, you see relatively the same thing. I had mentioned, growing season. So in the state of North Carolina, we are seeing a slight increase in the season, which again, for the ag folks can affect, when you plant, when you harvest, what's the yield going to be. And it's not just North Carolina, it's a lot of places in the US that are seeing an increase. There's also this effect that we've noticed the past couple of years, which, you have this increase generally, but, so things start blooming and then all of a sudden you have a hard freeze, and that sort of kills a lot of your crops. That happened here in North Carolina. A lot of apple farms a couple of years ago had this problem in which, things started blooming a little bit earlier than normal, but then there was one hard freeze and then it kind of destroyed some of their harvest by the time it was, time to go apple picking. We've also seen that there's an increase in drought as well. This is what the drought monitor looked like back in 2007. Some of you may remember a really bad drought here in North Carolina. There was also a bad one a couple of years ago in 2016 that actually led to some wildfires up here in the mountains of Tennessee and North Carolina. So there are drought effects to this as well. Again, when it comes to, people in agriculture and other sectors might be worried about this. Urbanization is also a thing here. The reds here indicate developed land, and I can pretty much pick out all the metropolitan cities. Like Asheville's over here. Here's Charlotte. Here's the Piedmont Triangle. Here's the Research Triangle, and urban heat island is a big thing where you have all these big cities that are building buildings, and it kind of traps in this heat. And so you could have areas of like downtown Charlotte being a lot warmer than its suburbs, and that can affect people as well. So this is sort of it's not necessarily a science physical issue, it's more of an infrastructure issue. And then health people, I know there's a couple talks on health here. Health, they really care about this too, because if you have an increase in temperatures, you're going to have an increase in extreme heat events, heat waves, and that's going to affect people that have heat related illness. It's going to affect, it's going to affect people like, infants, people over 65. There's things like poverty to consider, housing and infrastructure, access to health insurance. This is, not everybody has health insurance. Not everybody has great health insurance. People with pre-existing conditions, they're going to be exacerbated by this heat. And then I kind of briefly mentioned the energy piece. There's people that still don't have air conditioners. Some of us, air conditioning is a luxury. And something that not everybody has. So if you have warmer nighttime temperatures, for people that don't have ACs, their bodies can't cool down at night. So it's in the health world, folks like CDC and the Health Service of North Carolina and other places, they're very interested in this. There's actually another website here that you can go to that kind of spatially view this information for North Carolina. This is provided by the CDC, and there's two things showing here. So what's on the left here is people over 65 years living alone in a non-family household. So, you could take, if you consider the temperatures as sort of our exposure to heat and then lay it on top of this, now we can start looking for areas for people that are more vulnerable. We had this question at the beginning about who's most affected by heat, and obviously people, with no AC or homeless or, the elderly, they're going to be affected by this more than others. And then on the right, this is showing percent of population of a race other than white. So there's actually a great research that just came out a few weeks ago, and it was highlighted in the New York Times that talked about how redlining in urban areas of Richmond, Virginia, actually led to warmer temperatures in that area. It's a great read. I would highly suggest you all to go look at that. But it's not just Richmond, it's other places in the US as well. And then finally, you know, again, this talk is about temperatures. We're talking about the effects of temperatures, but it's not just temperatures. It's lots of other things are changing. We're seeing an increase in heavy precipitation. We're seeing an increase in sea level rise. We're seeing a decrease in the Arctic sea ice extent. And then, as I've already mentioned, we're seeing this, you know, increases in cooling degree days, increases in wildfires, increases in season length. So this is a very busy image, but the point is that warming temperatures are affecting everyone one way or another. And that's it. This is my last slide. What you see here is what we call a climate stripe. So it's just a visualization of temperatures over time. Reds indicate warm years, blues indicate cold years, and essentially here, more reds on the right, warmer temperatures recently. So thank you very much.
Thanks, Jared. We had one question that came in that maybe you could address real quickly. I think your global temperature map had grayed out areas in the polar regions, and I just asked if that's due to data availability. Do you want to just talk real briefly about what we know about the poles and how we represent it?
Yep, that's true. So data availability is very sparse in the Arctic and Antarctic regions. You only have a few stations. That graphic was provided by NOAA, so they have a very, very strict criteria to incorporate that, to put those, what we call grid boxes on the map. And they essentially, they're not there because there's just not enough data. That being said, the folks at NASA they've done a really good job at incorporating satellite data, and that does look at the poles, and they use some fancy spatial techniques to incorporate that information without losing scientific value. So if you look at the NASA plots, they are there. And what I should point out is that if you look at their data, you know, I'm not trying to like say one data set's better than the other because they're all really great, but NASA really shows a lot of warming at the polar regions. So I'll try and find that link and maybe drop it in the chat.
Awesome. Great. Thank you so much. I think that was a fantastic presentation. I'm getting a lot of good comments, compliments in the chat. So next up, we're going to do some kind of lightning round presentations, and we have a great lineup of speakers. So up first are Dr. Margaret Sugg and Dr. Jennifer Runkle. We're talking about the health effects of heat in populations of concern. And Jen or Maggie, if you want to go ahead and share your screen, I'll introduce you. So Dr. Margaret Sugg is an assistant professor in the Department of Geography and Planning at Appalachian State University, and her research uses innovative geospatial technologies and methodologies to address climate health interactions. She holds a PhD in geography from the University of North Carolina at Chapel Hill. And Dr. Jennifer Runkle is a research scholar at the North Carolina Institute for Climate Studies, that's NCICS. Her research interests include examining the health effects of climate change and variability, with particular interest in characterizing localized impacts for vulnerable populations. And she holds a PhD in environmental epidemiology from the University of South Carolina and completed her postdoctoral training at Emory University. So we're excited to have you both here today. If you want to go ahead and take it away.
Thanks, Rebecca. I'll get us started. Good morning, everyone. Jared, thank you for that fantastic presentation. I, just as Rebecca mentioned, work with both Jared and Tom at NCICS, and Maggie is a close colleague, and we have been feverishly pursuing research at the nexus of climate and health on a wide array of projects. But in the next 3 to 4 minutes, we're going to talk to you a bit about some of our earlier work around extreme heat. Next slide, please.
Okay, and I'm Maggie Sugg, and I work very closely with Jen Runkle, but I'm actually at Appalachian State University. And we're just going to go through some really quick case studies that we've been working on. We're more than happy to go into more details if people have questions. First, this is some of my dissertation work that I completed at UNC Chapel Hill. But I thought it's a great representation of heat-related illness in North Carolina. So this map is showing heat-related illness emergency department visits across the state. And what's really interesting is that, rather than urban areas, you really see highlights a lot of heat illness in rural areas. Some of you guys mentioned that in your chat. I saw some of the most vulnerable populations here in North Carolina are those rural, occupationally exposed populations. And that kind of leads into our case study that Jen will describe next.
Yeah, just so as both Maggie and Jared alluded to, all Americans will be impacted by climate change, but there are vulnerable segments of the population that will be disproportionately impacted on the, around the climate-related impacts of extreme heat. And those individuals are more vulnerable due to age, their life stages, their places of employment, housing stock, and next slide. And so Maggie and I decided to, kind of as our first project working together, to partner with outdoor grounds management workers. NIOSH estimates that anywhere from 5 to 10 million US Americans are exposed to hot outdoor temperature each year. In fact, a recent report showing projections in the Southeast estimates that worker productivity will dramatically decline due to extreme heat by 2100. So this is certainly an important issue for our state. So one of the science gaps, traditionally we have used weather station data to approximate humans' exposure to heat, and we know that weather station data is an imperfect proxy. So Maggie and I teamed up with a colleague at Mississippi State University, Dr. Chris Furman. He's a climatologist, and we invited university grounds management workers from each of our universities to partner with us on a project to explore the feasibility of using these tiny low-cost temperature sensors to measure and approximate workers' individual or personal exposure to heat. And we've published a number of articles on this project, and we'll just give you some high-level findings. Next slide. So just kind of in summary, we found that when looking across the three campuses, very distinct climatologies, that weather stations tended to underestimate the exposures for workers. We found there to be this mismatch between the workers' perception of their heat exposure compared to their actual heat exposure. It was oftentimes much higher. Not all work sites had a heat prevention plan in place, and that would be kind of room to grow, if you will. And we did note that there was a higher risk of heat strain in workers outside of the National Weather Service heat advisory warning. So during those kind of seasonally normal but warmer than average temperatures, we saw excess heat strain. Next slide.
Okay, and so that's just one of the projects we've been working on. Another one is kind of a new area of research that hasn't had much development, and that's looking at the mental health effects of temperature. So there's this really weird phenomenon worldwide. Typically with higher temperatures, you see higher suicide rates, and it's kind of counterintuitive. People kind of think, in the dreary winter, you'd expect to see higher rates of suicide. But in fact, the opposite's true. So it's been observed in parts of Asia, Australia, and then here in the US. Jen and I wanted to take it kind of a step further. And we wanted to look not only at suicide, but some of these precursor events to suicide. So mental health events that are not quite as extreme, but perhaps could be a precursor to the more extreme suicide. And we were interested in seeing if there was a relationship with hot temperatures as well. And so we formed a partnership with a service called Crisis Text Line. This is a service used by adolescents. So it's widely used by young people, I guess high schoolers, middle schoolers, as well as people under the age of 24. They have about 140 million conversations to date. So it's widely used across the US, and we wanted to take their data and see if there was an association with temperature and heat. And so we used this data, and we looked first at just the monthly distribution, and you can see here, we looked at 4 different cities for this particular study outside the state of North Carolina, because we needed a pretty robust sample size to construct a daily time series. But you can see that we're seeing the most crisis conversations in July. So some of the warmest temperatures are in July. And this is just looking at temperature. We did not account for other metrics of exposure like humidity. Interestingly, we see a drop in August, and we aren't sure what's causing that, and we're hoping to look into it further. We have a couple other data sets that we're going to look at to explore this relationship and kind of break it down. But for this particular study that focused on crisis events, we did see a pretty strong relationship with temperature. So the higher the temperature, whether it's minimum, so nighttime temperature, or daytime maximum temperature, we saw a very elevated risk. So a much higher risk of someone texting to crisis text line or experiencing a crisis event. And so this was a pretty significant finding, because we were one of the first people worldwide to look at some of these precursors to suicide. And then we're also looking at it here in the US. And so we're seeing a pretty strong relationship between high temperatures and these crisis events.
Thanks, Maggie. And I'm just going to tee this up. I know the next webinar is going to be focused on hurricanes, but Maggie and I have really enjoyed this partnership with Crisis Text Line, and there's so much utility and areas for exploration with this data set. We decided to actually take a closer look of the near real-time crisis response in youth during Hurricane Florence a couple of years ago, and this paper was recently published, and we found something very different. You know, what's really unique about this data is that we don't have to go through the hoops and hurdles of the traditional research process where you have to get approval, IRB approval, implement the study, et cetera. We're able to unobtrusively collect the crisis response or psychological response to extreme weather event in close to real time. And so we use this data to and actually found that there was a pretty immediate and sustained increase in crisis response for a number of mental health stressors like stress and anxiety. But the one in particular that was pretty alarming, and we're working closely with some, a few mental health clinicians to help us understand and take this a little bit further on the intervention side, but we found a pretty significant spike in suicidal thoughts during and immediately after Florence. And that is all that we have. Thank you.
Thank you. That was very, very interesting. And there were a lot of things that I for sure had never heard about before, types of research connections. So I'm really excited that this type of work is happening in our state, and we'll get to some questions after we hear from our next 2 talks. So next up, we have Dr. Matt Bertone and Dr. Clyde Sorensen. And Matt, if you'd like to go ahead and share your slides, I'll introduce you both. So Dr. Matt Bertone is an entomologist and the director of the North Carolina State Plant Disease and Insect Clinic. And as the entomology diagnostician, he identifies insects and other arthropods, including pests, research organisms, and to answer general questions for people all over North Carolina and the world. And Dr. Clyde Sorensen is an alumni associate distinguished undergraduate professor at NC State in the entomology department, and he does applied and basic research on the biology and management of arthropod pests, of tobacco and other crops. So excited to have you both here today.
Thank you. We're excited. And just to clarify, arthropods are insects and their relatives like spiders and mites and whatnot. So we're going to be discussing very broad generalizations about them. And I think Clyde is going to go up first.
Yeah, I'll go ahead and get started. And so one thing that's important to understand about arthropods, about insects and their relatives, is that for most of them, temperature is a very, very important facet of their environment. Most arthropods are poikilothermic, which means most of the time they're basically the same temperature as the surrounding environment. And so if temperatures change, it has a big impact on their function, their biology, their growth, their development. And insects and other arthropods are important to us because they're incredibly diverse, they're incredibly abundant, they're ecologically critical to the functioning of all our ecosystems. And of course, a lot of them are very significant pests of agriculture and other human enterprise. And so insects and other arthropods can be affected a number of different ways by changes in temperature. And one of the ways that we see insects affected by climate change is that as we're experiencing a warming environment, as warmer temperatures move in the northern hemisphere to the north, insects can expand their ranges, and arthropods can expand their ranges to the north. And we're seeing this with a number of important species, including some bark beetles that can have a huge impact on forest ecosystems. Also, when temperatures go up, typically temperature thermoclines kind of move up slope too in areas where we see mountains and other extreme kind of landscapes. And so as temperatures warm, arthropods can move up slope. And a lot of times when they do this, they displace the creatures that are already occupying that particular patch of land under a cooler environment. And a lot of these effects can be exaggerated in tropical regions because particularly in the tropics, most arthropods are adapted to very stable environments. And when the temperatures start changing, because there are so many more species and they're more tightly tied to particular environmental conditions, we can see more dramatic range shifts in the tropics. And sometimes we also can perhaps see more dramatic rates of extinction in the tropics. And yet another issue with latitude and altitude is that as temperatures warm, winters become milder. Pests that previously couldn't persist in certain areas because it simply got too cold in the wintertime are able to persist and establish. And so we see changes in that way as well. These two figures at the bottom of this slide here are kind of interesting because this sort of demonstrates what I've been talking about on kind of a geologic time frame. So this study was done quite a while back, but they looked at the fossil distribution of a set of beetles, and all of the beetles that are included in these two figures were at one time found in Great Britain, so in England. And hopefully everybody knows where England is. Matt, point to England on one of them. And now, in modern times, this was 11,000 years ago, all these beetles were found in Great Britain. And now, in modern times, none of them are found in Great Britain. And what we've seen is those that were more adapted to warm conditions have moved south. And those that are adapted to cold conditions have moved either north, or as you can see in the lower right-hand corner, they've moved north or they've moved up to higher altitudes in the Alps. And so this is a graphic, pardon the pun, demonstration that insects will shift their distributions as the climate changes. Matt?
And at the clinic, we receive samples from all over North Carolina, and over the years, we track new pests or new insects that are either native or foreign and are coming into the state. And just as a couple examples, these are actually native species to North America, to the southeast. but until recently, they were not found in North Carolina. So these were in South Carolina, and they are starting to creep their way up. Now, things like these palm flower weevils are harmless. They're just part of our fauna now. They're little kind of cute beetles that live on palm flowers. But things like palm leaf skeletonizer moths have caterpillars that feed on palms and cause a lot of terrible looking plants in communities and neighborhoods. So with all this fecal matter and feeding damage. So even native species, especially native species, will start moving up north more. And so we expect to see more species that were restricted to South Carolina and lower south to be coming into North Carolina in the coming years.
So even for insects that aren't changing their distributions, or they may be changing their distributions, but always been in an area like in North Carolina, as the climate changes, as it warms, it has a big impact on the phenology or the course of development of those insects. And so because insects in this part of the world spend the winter in a condition we call diapause, it's roughly analogous to hibernation. They break that diapause, they come out of their inactive period, oftentimes triggered by changes in the temperature of the air or the soil if they spend the winter in the soil. And as I said earlier, because they're poikilothermic, their growth rates are heavily influenced by temperature. To a point, insects grow faster when it's warmer. There's a breaking point past which it starts killing them, but in general, insects grow faster when it's warmer, which means that they can turn more generations over during a growing season if, on average, the temperatures are substantially warmer than they once were. So these two graphs on the side here are from a study that was done in Great Britain looking at the phenology of a couple butterflies. And the top graph shows that these two butterflies, especially Vanessa, especially the Admiral, have been coming out earlier and earlier every year. And this is a fairly old study. These trends have continued through this day. And the bottom graph is showing you that not only are they coming out earlier in the year, but they're out and around for a longer part of the year. So their active season, their active duration has been steadily growing as well. And we're seeing that in North Carolina with a number of insects that are just interesting to people, but also with a number of pest insects as well. We're seeing an increase in what we call volatinism, or the number of generations that insects can pass in a year. And so because of that phenomenon, we may in the very near future, and we're already seeing it to a certain extent, see that we're dealing with more chronic and more significant insect pest populations in some of our agricultural crops. Matt?
Another factor in a warming environment is going to be host suitability. So for plant feeding pests, plant feeding insects, the hosts, depending on the heat and also CO2 levels, are going to have different nutritional value to the pests and to these insects. And so they may actually be more nutritional or even less nutritional to those pests. And actually, a study by our own Steve Frank here in the department and his student Adam Dale showed that on maples with this scale insect, this doesn't even look like an insect, but each of these is a scale insect on a maple trunk or branches. When they looked at maples in different hot spots, basically, especially where there's urbanization and impervious surfaces, they had larger bodies and more embryos and more eggs produced in the hotter areas than the cooler areas, which is a sign that this is probably going to start to happen. This also may be linked to other things that we'll talk about in a second. But the arthropods may also shift to new hosts that become available. So as the plants move, pests that weren't normally on those plants may shift over to those new hosts as well when they become more available. Also, we've been seeing a lot with not only heat, but also drought stress and overwatering. So when we have hurricane events or large water events, and then drying and drought, we're seeing a lot of stress on plants. And when plants are stressed, they become more susceptible to pests, especially secondary pests that home in on those stressed plants. And also the secondary chemicals in the plants may change. So their defensive compounds, they may not be able to produce them depending on the amount of chemicals they're producing. And this actually, may change even the way things taste for food crops. Who knows? There's a lot of secondary chemicals we use as humans that are used for defending against pests that we actually like to eat. So there's all different things that can change either better or worse for these insects on their plant hosts.
All right, the last thing we'd like to address is that a lot of insects and other arthropods that we regard as beneficial for one reason or another can be significantly impacted by changes in temperature and changes in climate. And again, from Dr. Frank's lab, one of his students, April Hamlin, did some work looking at how native bees, not honeybees, but the native bees, which are far more diverse and in probably in the end, far more important than honeybees, which are actually an exotic insect. She did some work to try and establish what the effects of hotter temperatures were on native bees. And she discovered that a lot of the smaller native bees suffer under high temperatures. They disappear from landscapes that have abundant floral resources because the temperatures are simply too hot for them. And the diversity of the species also declines. In another case, some of the parasitoid insects that attack some pest insects, like some of the scales that Matt was just talking about, appear to have a different response to increased temperatures. And we see this fairly commonly where you have a host of pest species of insect which responds to temperature changes differently from the beneficial insects that suppress that pest population. And in one case, the parasitoids that attack a pest are simply not able to tolerate as high temperatures, and so they start disappearing. In other cases, because the beneficial parasitoids or predators that attack pest insects respond differently in terms of breaking diapause or in other respects from the pest, they break synchrony with that pest. And so they're not able to respond to changes in the pest population as efficiently as they would at cooler temperatures. And we see a reduction in pest control when that happens. So bottom line is that because insects and other arthropods are so dependent on what their environmental temperatures are and so tightly tied to what those temperatures are, changes in climate, in particular changes in temperature, can have a huge impact on the abundance, the occurrence, the distribution, and the pest significance of a lot of arthropods. Anything you'd like to add, Matt?
No, I think that's it. I think there's a lot of kind of hand waving because we don't know exactly what's going to happen because there's so many species of arthropods out there. We have tens of thousands of species in North Carolina alone, and then also the effects on their hosts. So it's basically a very complicated system and requires a lot of study for specific pests, beneficials, the host plants, and habitats. So it's a really complex issue, but we know that there is going to be change, and some of the empirical studies have been showing that already.
Thank you.
Okay, I'm gonna stop
That's
sharing.
really interesting, and that complexity was something I kind of knew a little bit about, but I think that really highlights it. So I will share my screen again. So last but not least, we have Lauren Thie, who I've interacted with a lot in the past, and I was really excited that she was able to join us. So she is the public health epidemiologist in climate and health at the North Carolina Department of Health and Human Services, and she's going to talk briefly about heat health systems in rural North Carolina.
Hello, everyone. I'll just say a few things. So I manage the climate and health program at the Division of Public Health at the State Health Department, and typically do a lot of work on heat health illness, especially when it's not a global pandemic that some of you may have noticed is happening. Around heat-related illness, we have a few specific projects that we do. It's all under the Centers for Disease Control and Prevention's framework. So if you want kind of just a great starting point for potential local level projects to protect human health in climate change, or to protect health for climate change impacts on kind of a local level, or even a state or territory or tribal level, you can visit the CDC Climate and Health Program, and they've got all kinds of things to get you started and kind of ways to think about overview of impacts. Here in North Carolina, we've implemented that framework to do some, pardon my phone noise, to look at heat-related illness and increasing temperatures that several of the panelists have talked about and Jared described. One of those efforts is providing situational awareness during the summer. So we do weekly heat-related illness emergency department visit reports. You can check out our website. If you look up North Carolina Climate and Health and Heat, it should pop up. But we're at the North Carolina Division of Public Health and Occupational and Environmental Epidemiology. And you can contact me to get those emailed to you, or they're posted up on the website. We also have projects in four counties in the Sandhills, Bladen, Robeson, Sampson, and Scotland, where we focus on doing targeted communication to some of the populations that all of you did a great job bringing up in the icebreaker. So we particularly focus on low-income earners, on older adults, on farm workers, and on youth. And I think if somebody has a specific question, feel free to follow up with me at my state email or maybe in the question time. I also saw that many of you were really interested in organisms. I'm guessing with NC State that some of y'all do all types of environmental and agricultural extension type work. So I think I'll just stop there to just give you a little overview of what we do and say that I'm happy to follow up with anybody afterwards. So.
Thank you, Lauren. Yes. Oh, great. Cool. So we're going to take just a short break because we have had some questions come in and I want to make sure that we can get to them. So I put 3 minutes on here. So if everybody can, maybe if you want to get up and stretch, but we'll try to come back at 11:12, if that's not too short, and we'll jump into some questions. If you come back from your break, we will be doing questions through the chat or through the raise your hand feature. Because there's so many of us, we're going to try to moderate it and kind of point to, which panelists, which speaker to answer the question. But with that, I'll be quiet for a moment and so everyone can get up and stretch.
Rebecca, I guess just leave any questions in the chat then, don't answer them. We'll leave.
Yeah.
And some of them I answered one, but we can come back.
You're fine. Great. I have 11, 12, so we'll go ahead and jump in if everyone is back. So just as a reminder, if you have any questions, all questions are welcome. Please type them in the chat, or if you are to click on the participants button on the bottom, usually it's on the bottom of your Zoom screen. There'll be a little option there to raise your hand, and I'll be looking at that. That's if you want to actually unmute yourself and ask a question. Otherwise, we'll kind of be reading them out of the chat. To start with, we just had kind of a overall question to see if we could get our speakers to respond to just really briefly. You know, we heard a lot about different types of research and things that we're learning. And so we just wanted to ask, you know, what do you see as the big, you know, capital B research questions that we need to answer when it comes to climate change and temperatures in North Carolina?
I can jump in. It's interesting, you know, I've been here in North Carolina for about 10 years, and most of my work has been on climate. My background's in meteorology. So you know, I've been really working a lot on climate for the past 10 years, not just temperatures, other things. But as I sort of come into this new decade of my career, I'm really interested in what I've been calling climate and, quote, something else. So, and I think depending on who you talk to, there's going to be that something else it can be a lot of things. And we've kind of touched upon this in the talks today. You know, we can talk about climate and health, or climate and agriculture, climate and energy, you know, climate and insert your profession. I mean, everybody's affected. As to what's the big one, again, I think it depends on, you know, who you talk to. For me, it's really about the people. It's who's affected. I've been, a lot of my work recently has been on, you know, who is most vulnerable to heat. You know, I kind of briefly talked about it in my talk, but, you know, if you add this sensitivity component, where are the people who are, you know, have health issues, and where, you know, the elderly, the young children, you know, and then that's sort of like the sensitivity piece. And you add something called adaptive capacity, which is like resilience. Like how can you prepare for this? You know, what cities have cooling centers? You know, where can people get access to water? You know, and that's what's interesting me more, especially in the state of North Carolina, because we just have a very diverse geography here, you know. So for me, the big question is who's affected, and it's a lot. So that's kind of my 2 cents on that.
I agree with Jared, and he kind of really hit a lot of facets. But, you know, I think in many ways climate change is this apocalyptic doomsday threat that none of us can really wrap our heads around. And I think that, you know, using this lens of health really brings it down into a much more narrow, digestible focus. And we realize that, you know, heat has a myriad of direct and indirect effects on our health. And so I'm in Jared's camp, and that's something that Maggie and I have been exploring. Like, what's the exposure response? Like, how much exposure to X amount of temperature elicits an adverse response in a population group? And we've been, you know, wanting to explore that in individuals with mental health conditions. Pregnant women is a relatively under addressed research priority. And even just back to what Maggie was presenting on that close to near time response from mental health in young people. How can we get better at, you know, understanding that and doing that situational awareness and intervention, you know, targeting these groups in close to real time? That's my 2 cents.
I'll add on to Jen because our work is so related. One thing we did find, I think, with the worker study and then some of our previous work with heat-related illness in North Carolina is, you know, you can identify vulnerable populations, but one problem we really have is like communicating that risk to them in a way that inspires behavioral change. And that's an area that no one's really looked at. And we're starting to just get into like, what is your perception of heat? And do you perceive yourself as high risk enough to adapt to it, to get into that adaptive capacity? So we actually see, you know, after 100 degrees, we see a huge decrease in heat-related illnesses. And I think that's because people see 100 degrees and they're like, oh, I'm not gonna go outside. But therefore we see a lot more, you know, workers at risk, a lot more heat-related illness at those climatologically normal conditions of 95 to 99. So I don't know how we can communicate to the North Carolinians that that's also a very dangerous temperature threshold. So yeah, me and Jen are trying to get at this, how to evoke behavioral change. And that's a really, really hard question.
So I'd add from our end, from a ecological perspective, that in North Carolina, you know, North Carolina is blessed with tremendous biodiversity, and we've got the greatest elevational change and the greatest, I guess, biome kind of representation of any state in the eastern half of the continent. And climate change is going to have a big impact on our biodiversity, and we don't have a real good understanding yet of exactly how it's going to change. It's also going to have an impact on the occurrence and the proliferation of invasive species, both plants and other kinds of organisms, including some arthropods. And so I think there's an awful lot to try and understand in terms of preserving the biodiversity we have, mitigating the effects of climate change on that biodiversity. And then one other thing I'd bring up is that, you know, it's not just heat that changes as the climate changes, but, you know, weather systems become more severe. The hurricanes, you know, we've seen this happen over the last few years where hurricanes are wetter and slower moving, and they have that kind of change has a huge impact on ecology, on agriculture, and on people. And then the last thing that's changing, and that's got very important significance for North Carolina related to climate change, is sea level rise. And our coastal areas are going to look very different depending on how well we mitigate the change in temperatures from one scenario to the other. And we have to figure out exactly what all the impacts of that might be.
Thanks. I guess we'll, if anybody else wants to jump in, please do, but I guess we can jump to some questions that came in from the chat, maybe?
Sure, we've got one probably for Jen and Maggie from Caroline. What is the hypothesis for why heat correlates with an increase in mental health issues?
You want to take it, Jen, or do you want me?
We can tag team. How about I set us up with the population and you do the mechanistic stuff?
Okay.
So just in general, we're starting with, do we see any association? We know that summertime temperatures are not the primary driver in mental health, right? That is not plausible. So we're just doing some population-based research. Do we see a signal when looking at the relationship between these higher than normal temperatures and spikes in ED visits for a number of health outcomes, including suicidal thoughts, depression, anxiety, even suicide attempts, and, you know, adjusting for demographics. And we have a really nice data set that helps us contextualize what's happening around the time of a suicide event to get at that. But then there's been some emerging research on the mechanistic physiologic side that I think Maggie may want to tackle.
Yeah, and again, we're just trying to explain, like, mental health is really complex, and we're just explaining a small part of that variation. So Jen nailed it perfectly. But there's a lot of hypotheses out there. Like, there's been some crazy hypotheses about, like, brain physiology and, like, brown adipose tissue, things I can't speak to intelligently. And there's been some studies that maybe adolescents are more sensitive to this temperature phenomenon with mental health. There was one study related to that. Some other hypotheses I've heard is it affects sleep patterns. So people are getting diminished sleep, and therefore, that affects their mental health. Another hypothesis that me and Jen have that has been suggested but not tested, and Jen came up with it, is perhaps, really high heat affects people's drug prescription. So when you're really hot or dehydrated, that could affect your prescription drugs if you're taking drugs for mental health issues. And perhaps that's why we're seeing some of these more severe outcomes. That hasn't been tested. These are all hypotheses, and people are working at trying to understand this relationship. It's a pretty new relationship that's being investigated with climate and heat and health.
Great, thanks. Matt answered a question already about, is temperature the reason fire ants are moving into the northern and western counties? And he said this is correct, fire ants are better adapted to warmer regions. So I don't know if you want to elaborate any more on that. Having had a personal experience with fire ants in South Carolina, I really hope they don't make it to Asheville. So maybe you can tell me I'm okay.
Yeah, they are moving up north, and as it gets warmer, the wintertime temperatures are milder. There's going to be less mortality in these ants. Again, they're nesting in the ground, so they're affected by soil temperatures. But yeah, this is what happened. Kind of classically, they started moving up, and they've kind of hit a ceiling here in North Carolina. Probably some in southern Virginia. I don't know the exact locations and range of all the fire ants. We actually have a western species of the black imported fire ant too. That's more in the mountains, and there's even hybrids of red and black imported fire ants out in the western part of the state. But even needle ants too, Asian needle ants, which are also a stinging ant, are apparently moving a bit more toward the north and western part of the state. So yeah, a lot of these critters are, starting to move up, and it's, even though we don't have personally any specific data on that as far as that it's directly related to the temperature changes, that's the prevailing thought. So, and I don't know if Clyde wants to add anything to that.
No, I just I guess I would counsel you to not hold your breath that they're not going to show up in Asheville.
Yeah, exactly.
Jared chatted that apparently he already has an issue. So
Yeah. Sorry.
we had one other insect question. Is there a possibility that insect resistance to chemicals could increase with increased temperatures?
So I'll field that. Insofar as some insects may have more generations in a year, and may, because they're having more generations in a year, may be treated more intensely with particular insecticides, it is possible that resistance development could be expedited. It's less clear whether or not higher temperatures will have a physiological effect on insects that would make them more likely to develop resistance. I will say, though, that in many cases, insects that have resistance genes, there's a fitness cost to carrying those genes, and sometimes it's possible that could be exhibited in a lower tolerance to really high temperatures. So in some cases, it may actually slow down the development of resistance because of the fitness costs associated with carrying resistance genes. But probably the most likely effect would be if we're seeing a particular pest species that is having more generations in a year, and so being selected more frequently over the course of a year. Anytime selection pressure is intensified, you're more likely to develop resistance. Anything else, Matt?
No, yeah, that's what I would have said too. Yeah, the generation time, that more generations means more chance for change and mutations, basically. And then what Clyde added, of course, about the direct applications and more pressure on them, that is just kind of a recipe for likely more resistance. But Clyde did explain it great.
Great. So we're coming up on the half hour. We have 3 minutes left. So I do have one other question that's kind of informed from the pre-webinar survey that I wanted to pose to the speakers, which is just how can we get involved? You know, if any attendees here today are interested in, you know, contributing to say like a citizen science effort or just, you know, getting involved, connecting with you on some of your research projects or just learning about what's happening. Can you share some ways that they can become involved?
I'll jump in real quickly. So we can always use more data on the phenology of the occurrence of insects. So just making anybody who wants to get into this just a little bit can learn a little bit about insects and maybe pick particular insects that are of interest to them. And just keep track of when they're seeing them, and that's important data. And for a lot of organisms, we don't have good data to go back to try and discern whether or not things are changing as we expect them to. So, for instance, this is just a weird thing. I take pictures of all the moths that come into my porch lights, and I identify them. And it's Matt will tell you it's a silly thing, but yeah, I've had 560 species of moths at my back porch light. And, you know, if somebody were to do something like that and keep track of the dates when they see particular species, that could be very, very valuable to us down the road. So that's one idea.
Yeah, not silly at all, Clyde.
I highly encourage everybody to track their insects. I think that that's a great idea, and I'm a great lover of insects and bugs myself and a budding entomologist. I did just want to mention 2 specific actions that I know of that are very protective of health, and one is taking quick action to reduce earth warming air pollution. We know that has huge health benefits, and you know, there are many state and national and international policies that have been laid out to do that folks can support and help communicate the benefits of those policies. And then I would also say on the adaptation side, the National Institute of Occupational Safety and Health has now thrice recommended that the Occupational Safety and Health Administration adopt a heat stress standard. There's several states have done this, and we know that that helps protect workers' health. And I didn't mean to cut off Matthew. I just wanted to plug those 2 bits of actions that we know will protect people's health, especially around extreme heat.
Yeah, I just wanted to add that, yeah, so I added 2 websites, Bug Guide and iNaturalist are both great ways to take photos and submit them. iNaturalist is much more well set up for citizen science. You can get the app and just take a photo of something with your phone and upload it right directly to it. And that is a great way to track and get identifications for critters, and also can help identify new pests to the state and to the region. And so we do sometimes, you know, people post these things and say, what is this? And they don't realize the impact that this pest or this thing could have. And early detection is really important.
So, oh, go ahead.
No, go Jared.
So I was going to mention 2 things from sort of the climate perspective. We keep, on this webinar and the last webinar, we keep mentioning this science report that came out for North Carolina. It's done by a great team called the Technical Support Unit that's housed in Asheville. It includes Tom and a few other people here from NCICS. They're gearing up to do sort of their next set of assessments on the national and the state level, I believe. They rely a lot on public comments, and I don't know like specific timelines and such, but be on the lookout for those because they really value the comments, and they've responded to every single one, I believe. So someone correct me if I'm wrong there, but they really value the public's input in that. So I would highly suggest that. My other suggestion, it just kind of popped into my head and it may be a little unconventional, but you know, we keep talking about vulnerability, you know, who's vulnerable, where are these areas? When we talk about the sensitivity, we have this information like age, gender, race, a lot of information. That comes from you all. That comes from either, something called the American Community Survey or the census. And as you know, the census is every 10 years and it's happening right now. So fill out your census, because that's actually going to help to some extent, kind of figure out where these vulnerable populations are. That just kind of popped into my head. I said, oh, that's interesting. So those are my two pieces of ways to help out.
Yeah, and in addition to, gaining more knowledge, there's a lot of information out there around climate and its myriad of effects. Just participating in a group, each of us have a bunch of different interests, and we have an angle on this whole climate piece that really piques our curiosity. And I think even just a quick Google search on community groups or activities kind of related around the topic of interest that really we gravitate towards is a great way to start. Research shows that, climate, it feels pretty, you can feel pretty down, low hope, but just by getting involved in these groups, it promotes health and resilience. And that's just an easy way just to go get involved.
Thank you. I will definitely be sharing these links and resources afterwards, and maybe I'll kind of do a little quick Google search and say how can you get involved, and pop that in there too. I do agree that it can be daunting. I myself struggle with that, and getting involved, connecting with others can be a great way to feel empowered. I know we're a little bit over time. I do want to thank everyone who's stuck around, especially our speakers. Just want to quickly say the next webinars we have planned in this series. This one was the second of 6, and so be on the lookout for announcements for those future ones. If you don't see an announcement, just contact me. My email address is at the bottom there. And I think that's my last slide. That's my last slide. So just want to say thank you all so much. I will stay on for just a minute in case any attendees or speakers have any questions. I do want to thank all of our speakers today so much for your time and your expertise that you shared. This was incredibly valuable, and I look forward to seeing where these research projects go.